Number 38. A bicycle racer sprints at the end of a race to clinch a victory. The racer has an initial velocity of 11.5 meters per second and accelerates at the rate of 0.5 meters per second squared for 7 seconds. What is his final velocity? Okay, so let's draw a little, let's draw a little bicycle here. Sure. And pretend the problem is about skateboarding, because the picture looks closer to a skateboard than it would ever to a bicycle. Okay, so for letter A, it's asking what is the final velocity. So he's starting with an initial velocity, as it mentions in the problem, right, of, what is it, 11.5, right? So the initial velocity here would be 11.5 meters per second. Okay, and he's accelerating now because he's trying to win the race. So his acceleration now, let me move it down a little bit. His acceleration now is going to be 0.500 meters per second squared. And he's going to be accelerating at 0.5 meters per second squared for 7 seconds, right? So it says that the time value here should be 7.00 seconds. Okay, and what we're looking to find is we're looking to find now at the end of this, the final velocity. All right, so do we have an equation now? We have to think about this. We need an equation that will relate initial velocity, acceleration, time, and final velocity. And we do, right? It's number 1 here at the upper right. So let's do that. So letter A is going to be the final velocity is equal to the initial velocity plus the acceleration times time. The final velocity is what I'm looking for. The initial was 11.5. The acceleration, they told us, was 0.500, and the time was 7 seconds. Okay, so let's just plug it into the calculator. So it's 11.5. Take, well, don't even need a calculator, right, because it's just half. So this comes out to 3.5. So 3.50, because I need 3 sig figs. And now when I add these two values together, so I have the final velocity now, just be careful about the value you're going to obtain in terms of significant figures. Okay, so this should now be 15, right? 0.0, right? Because I have to cut the answer at the at the tenths place instead of the hundredths place. Okay, so the units here would be meters per second, and that now completely solves for the final velocity. Let's move on now to letter B. So letter B. It says the racer continues at this velocity, okay, so the velocity we just found, to the finish line. If he were 300 meters from the finish line when he started to accelerate, how much time did he save? Right, so how much time did he save? Okay, so let's add in some context to the picture. All right, so he's traveling, okay? And he has to cover now to get to the finish line, which is here, right? This is the finish line. He has to travel 300 meters, okay? So I know that the displacement here is going to be 300 meters, okay? Now, it says, so the question is asking, how much time did he save? Well, in comparison to what? So let's say there's two scenarios here. In scenario number 1, the bicyclist doesn't accelerate. Right? He just travels at his initial velocity of 11.5 and he'll eventually reach the finish line. And that would take a certain amount of time, right? Now, if he though starts to accelerate like it was in question A, and he starts to accelerate, do you think that he would reach the finish line sooner? Yeah, he would, right? He would reach it sooner. How much sooner? That's the question. So what we can do is we can first find, and we'll first assume no acceleration, okay? So assume no acceleration. So that means his initial velocity was 11.5 meters per second. The final velocity would be the same, right? Because there is no acceleration. The acceleration 0. My displacement here, he had to travel 300 meters. Okay, and the time we don't know either, right? So time is question mark. So again, what we want to do is we want to try to find time. So we need to consider, do we know any equation that can relate these variables? And I think the easiest one might be the last one here. Okay, so if I have my change in displacement will be equal to 1/2 the initial velocity plus the final velocity, right, multiplied by time. I mean, we don't even need this written out equation. We can even use a simpler one, but it's just here, so let's use it. So this is x is 300. Then it's 1/2 of the initial velocity, which is 11.5, plus the final, which is 11.5, times my time. So this is 300 is equal to 11.5 plus 11.5, and half of that would simply be 11.5 t. So this actually works out to be just a simple x is equal to vt formula. Okay, now just divide out the 11. Oops, sorry. Now just divide out the 11.5. So now the time value, assuming no acceleration, right, it would work out to be 300 divided by 11.5. So 26.1, we got to have three significant figures here, so 26.1 seconds. Okay. Now, what happens when he does accelerate? So we have to think about this in a couple of ways. All right, there's really two parts now to this problem. So the first part we have to consider actually exactly what we considered in the part here in the picture in black. Okay, what I need to though do is I need to then find the distance that is covered here. Okay, so the distance is the question mark. Okay, and what I can do then is if I can find the distance here in black, then I now know once he obtains this final velocity that we calculated of 15, right? This is really, instead of equaling a question mark anymore, it really equals 15 meters per second. I know though from this particular point to the end, he's going to be traveling that at a constant, a constant velocity, right? There's no more acceleration. So essentially this works out to be a two-part problem here. This is like a part A and this would be like a part B. Okay. So let me just put this part in red. Okay, so this is my part A finding, okay, and this is part B. All right, so let's take this in pieces. So I'm going to do the work right beneath this. I'm going to just close this off a little bit. And now let's say this is assume that there is an acceleration. Okay, so for part A now, what we would like to do is, well, actually, do we even need to? Yeah, no, we do have to find the because we have to figure out how much left is to cover. So what I want to do is first find the distance here. Okay, so how do I do that? Well, I need to figure out an equation that relates initial velocity, right? Acceleration, time, final velocity I did find, so I can even use that. But do we have an equation that might be representative of those variables? Well, if we go back and we look, right, it looks like we can probably use equation number 2 for our purposes here. Okay, so let me just actually backtrack those circles off. Let's keep it a little neater. And let's write that equation down. So change in displacement is equal to the initial velocity multiplied by time plus 1/2 of the acceleration multiplied by time squared. So the displacement here will be equal to 11.5 multiplied by the time, which was 7 seconds, plus 1/2 of the acceleration value, which is 0.500, times the time again squared. Okay, so my displacement here, let's clean this up a little bit. Let's multiply some stuff across, times 7. So this is 80.5. This first part, 80.5, plus now, let's calculate the second. So 0.5 times 0.5 times 7 squared. So 12.25, but I need 3 sig figs, so this is going to be 12.3. Add those two together. Right, so this should simply come out to be 92.8. And this is meters. Okay. So 92.8 meters, he would have traveled now. Let me just go back to the picture. Let me erase this. Okay. So this part right in here now, this distance from this location was 92.8 meters. Okay, and remember, in order to cover this distance that we just found, it took him 7 seconds. Okay, the reason why I had to find that distance is because now I need to find the remaining distance in part B. So how do we do that? Well, you might say, well, if the whole length of the thing is 300, and he already traveled 92.8, just do a subtraction, right? So that'd be correct. Take 300, subtract 92.8. So this should be about 207, and we got to consider significant figures here, so it'd be 207. 207 meters would be left. Okay, so now what we need to do is now this is essentially my part B. Remember, this is the dividing point. So what's the velocity here? Well, the velocity here was the final velocity of the first part, right? So that's just 15. This is now my displacement that I just found, right? And remember the acceleration over this time frame. Let me just get rid of some of these circles here. Okay, this is just x. And remember the acceleration now in this part is 0. Why? Because, where does it say? He accelerates at a rate of that only for 7 seconds. So he doesn't keep accelerating. So once the 7 seconds is up, he stops accelerating. So now what I need to do here is essentially I know my initial velocity, right? The final velocity once the bicyclist reaches the end of the line, it will be the same, right? It'll still be 15 because there's no acceleration. So I can use the same formula I did for the part where I assumed no acceleration. Okay, so let's now move over to here, the bottom right for part B. But I can break this down into an easier formula, right? I can just do x is equal to vt. Okay, just to save some space. So my displacement was 207. Right, the velocity is 15.0. And I'm looking for now the time. So just divide out the 15.0. So now my time value, I'm going to put it up here. So my time value for part B is 207 divided by 15. 3 significant figures, it works out to be 13.8. 13.8. Okay, so this is the time for B. All right, now let's think about this. Okay, let's think about this. So the time for part A was 7 seconds, right? This is the time for part A. And then I just found now the time for part B to be 13.8 seconds. And this is for part B. So what would be the total time? Right, just simply add them together, right? So the total time will now be 13.8 plus 7. I don't even need a calculator for that, but I used it anyway, is 20.8. So 20.8 seconds. That is now the total time with the acceleration. Okay? So now we have to remember, what do we even want to solve? Remember, the question is asking how much time did he save? So let's go back over to here where I just started on the right-hand side. This is the time in which he would have crossed the finish line, assuming he didn't accelerate at all. It would have been 26.1 seconds, which should be longer than if he did accelerate. And it is, right? We just found it to be 20.8. So how do we find how much time he saved? All right, it would just be a subtraction, right? So let me do that. I'll do it right down here. Okay, so the time he saves now, so the time, I'll say saved, is equal to the time where we assume no acceleration minus the time of acceleration. So the time saved should then be simply 26.1 minus 20.8. So the time saved here Let's just plug it into the calculator. 26.1 minus 20.8. And this is 5.3. So this works out to be 5.3 seconds. I just need a quick drink of water. Excuse me 1 second. Okay. Man, this is a long problem. Okay, so this is finally the answer to part B. Okay. Now, oh boy, part C. One other racer was 5 meters ahead when the winner started to accelerate, but he was unable to accelerate and traveled at 11.8 meters per second until the finish line. How far ahead of him in meters and in seconds did the winner finish? All right. Either my brain is fried at the moment or this question isn't making too much sense. So one other racer was 5 meters ahead of when the winner started to accelerate. Okay, so let me draw a little sketch. I'm going to draw a sketch in the upper left-hand corner. Okay. So here we have a racer, right? He was 5 meters ahead when the winner started to accelerate. So I assume that the winner came from behind, right? So here, this distance is 5 meters. They're separated, okay? And I'm thinking that the finish line will be somewhere over here. Okay. Okay, so one other racer was 5 meters ahead when the winner started to accelerate. But he was unable to accelerate. Who's he? These questions are sometimes not detailed enough. But he was unable to accelerate and traveled at 11.8 meters per second until the finish line. How far ahead of him in meters did the winner finish? Okay, so I will assume, so by some friends, clinch. Okay, so the person that we just calculate all the information for, sorry it take me a second, but there's too much he and him and this and that, and there's not enough definition in what they're talking about. So it's a little hard to wrap your head around. But what we just calculated, if we go back in the problem, we just calculated information about the winner, right? So this guy's the winner. And we just calculated everything we needed to know, okay? Meaning that his acceleration, how much time he saved, and all this, the total time it would have taken him to get from the point where he is to the finish line, etc. So, and now it says the other racer, though, was 5 meters ahead, so this is the loser, right? Poor guy. And so he's 5 meters ahead when the winner started to accelerate. But I'm going to assume the loser was unable to accelerate. All right, now let's make it a little more sense. See, they really need to give you more context. So the loser was unable to accelerate and traveled at 11.8 meters per second until the finish line. So this guy is traveling at a velocity of 11.8 meters per second until he reaches the finish line. Now remember back to the prior problem that the total distance from the winner to this finish line was 300 meters. Okay, and that means that the distance from now the loser, right, to the finish line would then be simply 295 meters because he's 5 meters ahead of the winner. Okay, so how far ahead of him did the winner finish? Oh, okay. So how far ahead of the loser did the winner finish? Okay, so now we can do this. All right. Man, these are... the wording is terrible. So, okay, so we know the velocity. Okay, we know the displacement. What we need to now do is solve for time. Okay, so a simple velocity formula, right? Velocity is equal to displacement over time. So his velocity was 11.8 meters per second. He had to travel a total of 295 meters. And now I want to solve for the time it took him. So just doing some math, just do a cross multiplication. So really it's going to be 295 divided by 11.8. So this works out to be 25 seconds. Exactly. So 25.0 because I need 3 sig figs seconds. Okay, great. Now, that's the time it would have taken the loser to go from his position to the finish line. But if it took the loser 25.0 seconds and the winner go down to the bottom of the, not the bottom, the middle of the page, and it took the winner 20.8 seconds to complete his, to travel his distance, it's now asking how far ahead, right, of him in meters. Now, I don't know how far. I'm sorry, in meters and in seconds. Okay, so in seconds we can calculate this, right? So to find now the difference, we would just have to take the difference, right? So what I would do here is now simply take how far, in order to find how far ahead, it would simply be the 25.0 seconds and subtract out now the 20.8. Okay, so this is now the time ahead that the winner finished. So this is 25 minus 20.8. Okay, so 4.2. So he finished 4.2 seconds, 4.2 seconds ahead of the loser, right? So now what we can do is we know that the loser now will have to travel an additional 4.2 seconds after the winner crosses the finish line. So now, in order for me to figure out how far behind the loser is, I can just use a simple v equals x over t formula. So I'm going to do that, and I'm running out of space. I'm going to do that down here on the bottom. Okay. So again, velocity is equal to displacement over time. I know the loser's velocity was 11.8 meters per second. And I don't know the distance he has to still cover, but that's what I'm trying to find. But I do know he's going to have to travel 4.2 seconds longer, right, than the winner. So if this should hopefully make a little sense here, that in order to find the displacement that he needs to travel or how far behind he is, I found then the time difference, right, or the additional time he would have to travel, and then all I need to do is multiply it by his average velocity there. So let's just do the math. So this works out to be 11.8 multiplied by 4.2. And 4.2, yeah, only two significant figures here, so this answer should be 50. So 50 meters. So the loser is 50 meters behind. Okay, so this one is the answer to letter C, as well as this is the answer to letter C as well. And man, we finally completed this whole problem. Complex problem, difficult problem, many difficult steps, but I hope it kind of makes a little sense. We just have to kind of get some context to letter C. We got to tweak the he's and the hims and all this to winners and losers and try to be able to differentiate it a little better. But anyway, I hope this helped, guys. If you wouldn't mind, just please quickly press that subscribe button. It'll only take a fraction of a second. Both my sister and I would appreciate it so much. All right. Thank you guys so much. We'll see you next time.